Hello, and welcome to this session, Plebs vs. Pros, how to look like you use Excel for a living. My name is Tim Heng, and I am a director of the consulting firm Some Product, which is helping to organize this conference. Hopefully you're enjoying the sessions so far, and continue to enjoy them for the rest of the event. In this session, we're going to look at some useful tips on how to make your spreadsheets look like a professional made them. A pro, or a professional, is someone who's not only skilled at what they do, but they make a living out of employing those skills. A pleb, for those unfamiliar with the term, comes from ancient Rome, referring to the common person. For our purposes, this would be someone who might dabble in Excel, but isn't really good enough to make a living or find a job that requires you to be really good with spreadsheets. So our goal, over the next 45 to 50 minutes, is to show you some of the common ways that people use spreadsheets and some quick ways to spruce it up like a professional built it instead. To start off with, we're going to turn our attention to what some people consider to be advanced. To start off with, we're going to turn our attention to what people often consider advanced, the VLOOKUP function. To be honest, VLOOKUP is often seen as a pretty pleb tool on the face of it, because there are so many other tools in the toolbox that can be used instead that showcase your professional skills. We'll then turn our attention to cleaning up your spreadsheet. They say that you shouldn't judge a book by its cover, that the contents may be better than you think at first glance. Well, from personal experience, glancing at an Excel spreadsheet, you generally know what you're going to get. If it looks bad at a glance, it's probably not going to get any better. We'll talk about some presentation tricks you can use to make your workbooks look like they're professionally developed. Finally, as we go through a range of examples, we'll be highlighting different tools you can use to run checks on your files before you send them out. These are the things that you can do to avoid making common mistakes that a professional would catch or not make in the first place. So, without further ado, let's get going. This is not going to be a death by PowerPoint deck. We're basically going to jump straight into some Excel files and look at some examples. So, let's start sharing our screen. Okay, so here's our first example. We're going to be looking at the VLOOKUP function. Generally speaking, the VLOOKUP function is trying to solve a task where you've got an item and you're trying to find a result from a table. So in this case, we have a series of salaries that might be on this table and names associated with them. And so for a given input name on the right-hand side, we might try and find a particular salary. So for Billy's name, we might use the VLOOKUP function and then pick out the name that we're searching for. Typically, we'll find it in this table. The salary is in the third column, so we'll type in the number 3 here. And let's just say we're going to use an exact match here, which most people do. So there we have it, a basic VLOOKUP function. Look up Billy's name in this table, pick out the third column, make sure we get exactly Billy's name, and that'll give us the answer, 60,000, which corresponds to Billy's salary. Likewise, if we were to type in a different name, Billy IE, that's going to give us an incorrect answer because we're looking for an exact match. So far, so good. Is this a pleb or a pro formula? Well, quite frankly, it's a bit of a pleb formula, as I mentioned before. A lot of people criticize the use of VLOOKUP, basically because it's prone to error. There are a lot of things that can go wrong with VLOOKUP. Give you an example. Suppose that we had a table here and we've suddenly got an extra name, an extra column that comes through. We've got a first name here. If we add a column for a surname, we can type in some surnames, but the damage is already done. You can see in the VLOOKUP, it's now picking up Billy's new salary of $26. Why is this occurring? Well, it's occurring because the VLOOKUP has a hard-coded 3 in the formula. This is a really common thing that people do when they use VLOOKUPs. They say you want a value from the third column, so they type in 3 to get that value. The problem is that when you insert rows or insert columns into your VLOOKUP and HLOOKUP formulas, you'll find that hard-coded 3 doesn't change. It stays in place and it doesn't update to 4 or shrink to 2. So for example, if I were to undo the surname and say if I were to remove the age column, what you'll find is that the formula just doesn't work. This is probably one of the biggest causes of errors in spreadsheets when people use VLOOKUPs. So, how do we get around this? Well, there's a couple of tricks that we can use. Instead of using VLOOKUP and hard-coding the 3 value, what some people will do is that they will look at the columns. And so there's a couple of tricks that you can use here. Some people use the columns function, selecting the names of the columns. Now what this has the impact of doing is it counts the number of columns between the name and the salary. And so by definition, if you were to increase or decrease the number of columns accordingly, then what you'll find is that now we've got 6 columns, so the VLOOKUP is going to pick up the 6th value accordingly. So this is a pro move to work around some of the problems with hard coding values into your VLOOKUP function. Whenever you see a tool like this, you know that there's someone there who's built a VLOOKUP and realized that this is a potential problem in the future. Absolutely a professional move. However, there are still some other problems with VLOOKUP that commonly arise. One of my bugbears with VLOOKUP that people don't realize is that it turns the entire table into a dependent cell. Suppose we looked at that example earlier, where someone may have deleted the age column. Well, the question is, are we allowed to delete the age column? Is it being used in a formula somewhere in the spreadsheet? To test this, we can go to the Formulas tab and find these trace dependents. So if I were to click on a name, click Trace Dependents, we'll see that that name cell is being used in the salary function. If I were to click on the salary item, I could do the same thing. But then if I were to click on the age, I trace dependents and I can see that the age column is being used in this salary. Well, first of all, that doesn't really make any sense because age and salary, shouldn't have anything to do with each other. But secondly, we know from the way that we've set up this VLOOKUP function that we could remove all of the contents of the cell and it would have no impact on the result, because the VLOOKUP is effectively taking the values from the name and the values from the salary column and ignoring everything else. So why bother having the age column referenced by the salary result at all? It doesn't really make any sense. It means that when you've got particularly large tables, suppose that you've got a table with 20 or 30 columns, it's very difficult to work out which columns are actually used on purpose and which columns are simply used because they fall within the VLOOKUP range. So let me remove these arrows and let's see, what other functions can we use instead of a VLOOKUP? Well, the most common example that we've seen is the use of an index and a match function. This is what most professionals will use when they're trying to find values out of a table like this. I say most because certainly there are people who would prefer to use a VLOOKUP in certain instances, and my understanding is a VLOOKUP still is faster than an index match, which is pretty cool. But generally speaking, index and match are preferred. So if you haven't used these before, let's take a look. Match. The match function is essentially looking up where Billy's name fits in this list. So we'd say match Billy's name, find the list of names that we're searching through, and then we've got this exact match or approximate match again. So I'm going to use an exact match again. This is not intended to be a session on how to use these functions. This is really about just trying to take that VLOOKUP and tweaking it to make it more professional. So I'm not going to go into a huge level of detail in these. If you are interested in how to use these functions better, do check out our website. We've got lots of resources on that. So this match function is basically saying Billy appears in the second row of this column. The index function essentially says, let's find our list of results and let's pick the second row, just say. But, instead of hard coding the two, maybe we can refer back to that match function. So in this way, we've got two functions here that say, A, Billy's name is in the second row, and B, let's find the result of that second row in the salary column, thus giving us $60,000. So what we can then do is combine these two together, because to really make it comparable to the salary VLOOKUP, we need this to fit in one cell. So I'm going to take that match component, I'm going to copy that, just Control-C, and I'm going to pop back into the index function, find that reference to the match result, just paste the match formula in place there instead. And so here we have it, our final formula result. We've replaced the VLOOKUP with this combination of index and match. And the idea is that we'll not only be able to insert rows and insert columns without breaking things, but also that age column in the middle and any other columns that might exist in this table will not be referred to as part of the precedent cells of this formula. You can see that this formula only refers to the name column and only refers to the salary column, nothing in between. This makes it a lot easier to track what information is actually relevant and what information could be removed if we wanted. So, index match is the ultimate pro move that you could use to avoid using a VLOOKUP. Of course, nowadays, there's actually an even better function out there if you're not aware. There is also XLOOKUP. XLOOKUP allows you to do exactly what that index match does, looking for Billy's name in this list of names and finding your list of salaries as your result. The basic XLOOKUP form is pretty similar to index match, but we're doing it in one function now. Now using XLOOKUP instead of index match shows that you're either a professional or a real Excel geek, and chances are if you're attending this conference you're probably both, let's be honest. So XLOOKUP is available in the monthly channel of Office 365 nowadays. I think it's about to come out in semi-annual if it hasn't already. And it's not available for versions of Excel 2019 and earlier, 2016, 2013, etc. So I'm not going to say that XLOOKUP is the professional way to build spreadsheets, because it's not necessarily going to work in all spreadsheets. And this is something about being a professional that you need to consider, right? It's not just a case of using the best, fanciest functions, it's about getting a result for whoever you're working for. So if you're at a company that doesn't have Excel 20, or doesn't have Office 365 and only has, say, Excel 2013, then XLOOKUP's not actually going to help you land that position because you can't use it. So this is just something to consider. A lot of people will say, yep, use XLOOKUP, it's better than the others, but you need to make sure that it works. Alright, so here's another thing about the use of VLOOKUPs and XLOOKUPs and index matches and so forth that doesn't actually involve looking at the function itself. The other big thing that happens when you use a VLOOKUP is people forget to extend the size of the VLOOKUP when you add someone new to the table. Suppose that we add Faye to the table on a different salary. If we were now to type Faye into the name, we'll find all of these break. And that's a problem. Clearly, we've got an extra item in the list, and we want to make sure that will sort of be included in our functions. A lot of people will sort of get themselves stuck when they're working with VLOOKUP and they get new data in the next month, and they require people to kind of drag their formula down each month to pull in the extra items. That's a really pleb move, I'll be honest. So, we're going to look at ways that we can work with this instead. And for me, this is through the use of tables. Now, for most people, I think this would be a table. But for a professional, this is just a bunch of cells. To turn this into a table, we can go to the Insert tab, click on the Table button, That'll convert this data to a table. We can see that it has headers and it has values, so we'll tick that, hit OK. And the nice thing about tables is that formulae will automatically expand when they refer to the entire length or size of the table. So if I were now to add Faye, again, let's call this, 35,000. I can type in Faye here, and suddenly the VLOOKUP, the index match, and the XLOOKUP have all expanded to encompass the extra rows in the table. Now, isn't that cool? This is probably one of the most overlooked tricks in Excel. People have been building data sets for donkey's years, and they've been fussing with this notion of having to extend their formulae every month or every day or however frequently that your formulae need to be extended. I know that professors at Harvard were caught out when they were doing some modeling for countries that have high debt to GDP ratios. This is research the entire European Union was basically relying on in terms of the response to the global financial crisis back in 2008. And in their workings, they had a spreadsheet that they worked on where formulae or the table had data added to it, and the formulae hadn't been extended to encompass the additional data. Not to say that that was the primary reason that their findings were wrong, but it was certainly one of the reasons why their findings were in error. And you've got, national governments that are making decisions off the back of their research. So certainly it's really important to make sure that your formulae that you have extend to the entire length of your data set. And using tables is a really fantastic way to make that happen. So, using tables, definitely a pro move. Keeping things just as a set of cells and numbers, yeah, not great. Hopefully that gives you some ideas on how you can take your humble VLOOKUP and turn it into something that's really quite professional. Okay, enough of this example. Let's go take a look at something else. Here we go. I've got a new example here. This is a really simple financial model. Now, financial modeling is one of those things that a lot of people use Excel for. Making forecasts, producing financial statements, and so forth happens to be one of the things that our company is particularly good at. What I'm showing you here, though, is an example of, I guess, not really very much. It looks like a simple P&L. We've got some years going across the top. We've got our profit and loss coming down from revenue to EBIT. We have some depreciation that's getting calculated. So, if someone was applying for a job at your company, and this is what they handed you, to say, this is how I build spreadsheets, would you hire them? I think for most people, probably not is the answer. There's a lot to work on here. And as we continue on through the spreadsheet, we'll see some of the issues and some of the problems that people will often do to get a spreadsheet to work, but are clearly not professional. So there's a half dozen things that we can do to this to basically spruce it up and make it better, I guess. Make it easier to work with and easier to see what we're doing. So I'm going to make a new page, and I'm just going to copy everything over. Oops, let's copy and paste everything over from that first page, so we can start with something fresh. So the first thing of all that I want to highlight is the concept of styles. Now, I think it's fair to say that this spreadsheet has no style, full stop, both figuratively and literally. Now, figuratively, it's ugly. That's why it doesn't have style. But literally, there is a feature called Styles in Excel. You'll see this Styles section in the Home tab on the top right-hand side here. If I were to open up these styles, I can see that we've got different predefined styles or predefined tools that I can use to format these cells in a way that makes certain items stand out, or make certain items fade into the background, or in other ways highlight different elements that I want to showcase. So there are two styles here that I've set up in advance, the assumption style in particular, and the subtotal style. Now the subtotals should kind of speak for themselves, right? I've got this EBITDA line here. If I were to remove the grid lines, you can see this doesn't look like anything. However, if I were to select these and apply that subtotal style, then at least it's a little bit more obvious that this EBITDA line is intended to be the sum of the items, or revenue minus COGS minus OPEX. It's going to be totaling up those items accordingly. Likewise with the EBIT line, and likewise with our total depreciation. Great. So that adds a little bit more style and a little bit more presentation to this. But here's one really useful element of styles. Styles are not so much for the end presentation, but to help people work out how to use a spreadsheet. And one of the most common types of styles you can have is this assumption style. The idea that you've got some hard-coded values in here that really need to be kind of identified so that people could change the revenue, but not change the formula associated with that. So you might highlight these items here and say those are assumptions, and this item here and say that's an assumption, and so forth. Now this is actually a bit of a pain, right? Because if you want to highlight each and every single item on this sheet, well, first of all, you've got to go through and find all of your hard-coded numbers, which, if you've been building the spreadsheet for a while, that might take a bit of a while. So here's a trick. And again, this is one of those professional tricks, right? If you hit F5 or Control G, both do the same thing, you'll bring open this Go To dialog box. And this is a special trick because you have to click the special button in the bottom left-hand side. There you go. So what we're going to be looking for are hard-coded values, constants, things that we've entered directly into the cell and aren't formulae. So we're going to click on this constants button, but at the same time, we don't want all these labels to be selected as well. So we're just going to find the numbers. So what this Go To Special button does is it basically searches through the entire spreadsheet, so this sheet specifically, not the workbook to be precise, this sheet, and we're asking it to find anything with a constant and anything with a numerical constant, hard-coded number. So when I hit OK, it's going to go off and select all of the cells that have hard-coded numbers in them. Brilliant. And this is great because now I can apply that assumption style to all of those cells. Fantastic. Pro move, completely. Okay, so this spreadsheet now has a little bit more style than it did 2 minutes ago. What else can we do with this? Hold on, let me rename the spreadsheet. This is the styles spreadsheet. So I'm going to copy this out to another sheet, and I'm going to turn my attention to the financial statements. Now, one of the things about financial statements is that the values in here, usually what you'll find is that they are positives if they're income generating, negatives if they are expenses. What we're seeing here right now is that we've got positive revenue, positive cost of goods sold, positive OPEX, and EBITDA has to take 1, minus 2, and 3. Likewise, EBIT is EBITDA minus the depreciation. Now that in and of itself is not bad, but it's a little bit of a pleb move. Most professionals in the finance and accounting space will actually present these as positive numbers for revenue, and then they'll use negative numbers for the cost of goods sold, and negative numbers for the OPEX. Let's change those to negatives, with the intention that EBITDA will simply sum up the revenue, COGS, and OPEX. Likewise, depreciation will usually be presented on the financial statements as a negative, so that the EBIT we'll add them together. And in this way, we're basically seeing that items should be presented in a form that is positive or negative based on whether they're inflows or outflows. If you're working with cash, for example, a positive cash number is always going to be a cash inflow, and a negative cash number is always going to be a cash outflow, regardless of what the label is. This is particularly important when you have things like net interest or any sort of net movements where values could be inflows or outflows. It's really difficult to try and understand when you're using the spreadsheet after the fact whether something should be positive or negative. So if you just work on the assumption that positive is in, negative is out, or positive is good, negative is bad, then the financial statements are much easier to kind of read and understand. So while we're on the topic of this, in terms of it being easier to read and understand, let's look at some of the number formatting. Negative signs like this in front are perfectly fine, and they tell the story appropriately. But they're also, again, a bit of a pleb move. The majority of professionals that I know will consider brackets for negative numbers to be the preferred option. And in fact, looking around the rest of the spreadsheet, the lack of commas, the rounding that goes to different amounts, this general number format is really not going to work for a professional presentation. So what we're going to do is select all of the numbers here, and I'll select these numbers on the left-hand side, which are also in that sort of positive large number range, not the percentages. And I'm going to change the number formatting. So you can hit Control-1 to open the Format Cells dialog box, or click on the options, Format Options, and we're going to create a custom number format. So what are we going to do with this custom number format? We're going to make it 0. So if it's a positive number, it'll always be shown as just the value of whatever it is. We're going to have semicolon, bracket 0, bracket, to show the negative numbers being what they are. And then often when we have a 0, we'll want to see it as a dash instead. So that's where we're going to put the hyphen. Okay. So if I were to change that, and we'll set the number formatting to this, that gives us brackets for the negative numbers. Doesn't quite take us all the way there though. So we want commas as well. So instead of using 0, we're going to use this tool that says hash, comma, hash, hash, 0 instead. Hash, comma, hash, hash, 0. Pound for you folks in the United States. So putting the pound symbols or hash symbols or number symbols or whatever you want to call them, they effectively show optional numbers. So numbers that aren't required to be shown, but if they're there, we'll show them. The commas will help us see that it'll add commas in between every third digit. There we go. Okay, so that's the next step. Finally, to make this really professional, so one thing that you might notice is that these numbers don't quite line up. The commas don't quite line up. This is often a point of frustration for people who work in spreadsheets. So to make them line up, here's the final part of this number formatting cool trick. You can actually leave space on either side of the numbers in order to kind of just push it that little bit to the left in order to make it work and make it line up perfectly. So instead of putting a bracket in front, we're going to put underscore bracket. And at the back, we're going to put underscore close bracket. We'll do the same thing for the dashes as well. And what the underscore does, it basically says to Excel, leave this much space on the side of the formula, on the side of the result, as a blank space. And that's just going to be enough to push our positive numbers across, leaving space for a bracket on the back end, to have all of our positive numbers and negative numbers start to line up now. Completely professional move. So, there we go. These are our financial statements. Alright, hopefully everyone is managing to follow along. So, let's move on to the next step. Let's create a new sheet. And in this sheet, I'm going to turn around and look at the years, because currently these are all hard-coded. Certainly we might be able to do something where we actually say, let's start off with a 2020, and then we'll just add one and add one and add one. But one of the things about the years is that it's a little confusing. Are we talking calendar years? Are we talking financial years? What periods are we looking at here? Now, in some jurisdictions, the calendar year and the financial year happen to be the same. That's all well and good. But for us, it's a little bit harder. In Australia, we work on a June financial year end, which means that 2020 could mean 1st of January to the 31st of December, but could also mean 1st of July 2019 to 30 June 2020. So, how do we tell what these things are? Well, often what we need is a period start and a period end date. Period start, period end. And in addition to this, it's probably a good idea to actually see what is the start date. So off on the left-hand side, I'm going to put a start date of the 1st of the 1st, 2020. This is a really good choice for me because the 1st of the 1st could either mean month and day or day of the month. So it's ambiguous. But in actuality, because I'm working in Australia, this is day, month, year. So I want this first column to have a period start of the 1st of January. How do I know when it's the first column? Well, I'm going to insert a row just above and create what we call a counter, which will allow me to take the previous number, plus 1, which we're going to copy to the right, and now I know what period each of these columns represents. So in period 1, actually, you know what? Period 1 is going to be start date. Period end is going to be, we're going to use the fancy EO month function, end of month, taking that start date and pushing it forward 11 months and taking the end of that month, which is going to be end of December, or 44,196. No, 44,196 doesn't actually tell us anything. So let's make it 1st of January to the 31st of December. And in the next period, we're going to have that being equal to the period end plus 1. I think we can copy this formula to the right, and in fact, we can probably copy all of these formulae to the right now. So this is now an assumption. We'll make that an assumption cell, and there we go. We've got a time series. Now, for those who are about to blast me, this time series is not perfect yet, but there are other things that we need to fix first. So we'll come back to that point. If you're not sure what I'm talking about, that's okay. It means you're a pleb right now, but we're going to turn you into a professional shortly. So this is our time series. When you're working in Excel, when you've got some sort of time period data, having a time series is going to be really good in order to make your data speak better. So rather than just looking at $10,000 of revenue, we now have a good sense of when that $10,000 of revenue actually occurs. So having that period start, period end, having a counter at the top, completely professional moves that you should have in pretty much every spreadsheet that you build that has a time series. Okay. So the next one really makes your spreadsheet that much more professional. So let's copy all this out, put it in place here. This next one is what I call separation of inputs and outputs. This is one of the most important things that you can do in a spreadsheet working professionally. So all of these assumption cells, or where they're required, and in fact I'm looking at these cells here, these years probably aren't required anymore, so let's use the year function and get that value coming through. Let's just copy and paste these formats over. I'm going to copy that back to the time series page 2 because that's going to fix it up. And this is the problem when you're recording things relatively live. Okay, so is that right? That's right. Let's get rid of those error messages. Okay, so when you're working with any sort of data, you've got all these assumptions all over the place. But unless you scroll all the way down the page, it's going to be really hard to find where they all are. Working in actual models that I've seen in real life, I found assumptions several sheets into the model and buried 9,000 rows down a sheet in places that you wouldn't really expect. So this separation of inputs and outputs is really important to help try and consolidate all those inputs into one spot. So what we're going to do, we're going to insert a couple of lines here first. And we're going to create a section that's called inputs. And you know what? We're going to use that styles tool to make it really clear that these are the inputs over here. So what are all the inputs going to be? Let's insert some extra lines over here. And let's have our revenue. Revenue in the first period is going to be $10,000. OPEX. OPEX is going to be $4,000, $5,000, $6,000. In fact, you know what? I'm actually going to make these positive because realistically, that's how you will think about them when you enter it. Again, pro move. The resulting cells need to be negative, but we're going to give it to the users in a way that makes them feel that they're entering it in correctly. The depreciation rate, 25%. We're going to pop that in place as well. Finally, the capital expenditure. Scroll back down the page again. Let's find the CapEx, copy, paste it back at the top. Finally, we're going to have a heading for our calculations, which we're going to style the same way that we did before. So here are our inputs. And then for all those cells that we had before, which were previously hard-coded, we can link those back to the inputs. Link these back to the inputs. Link this one back to the inputs. And link all of these back to the inputs as well. And then, actually, what I'm going to do really quickly is just take all of these cells, because these aren't assumptions anymore, these are now normal cells. That should still be a percentage. Normal, although they should probably be the same number formatting as all the rest. So I'm just going to copy the number formats and paste them over. Paste formatting. There we go. So we've got our calculations, which are now linked back to our inputs, which means that if we need to make any changes to this file, we can come to this input section here to make those changes. Brilliant. So another pro move. Here we go. Let's look at something else now. I'm going to take all this, copy it into another sheet. What's the next pro move that we can look at? Well, if I go back to our revenue, we had revenue for that first period, 10,000. But then every period thereafter that is increasing the result by 10%. Now, hard coding in the middle of a formula is just as bad as hard coding in a cell itself. So rather than having this 10% being kind of built in and hard coded into this formula, let's separate this input out as a separate item as well. This is what I might call parameterization. So I'm going to insert a new row here underneath revenue, and we'll call this revenue growth. We'll take the input style and we'll make this 10%. If I look at our cost of goods sold, again, it's multiplied by 0.35. Same problem. So we're going to insert a couple of rows here. Whoops, that wasn't what I wanted to do. We're going to insert a couple of rows here. We'll take the COGS percentage of revenue, and that's going to be 35%. The OPEX is growing by 10% in the future as well. So we'll create a new row here. Call this OPEX growth. And so I can go into all of these formulae now and replace those hard-coded values to references back to the input cells. So it'll take $10,000 times 1 plus 10%. copy that to the right. I'll take, let's take that hard-coded number and replace it back with this percentage instead, anchoring it down so that we can copy it to the right. Find our OPEX numbers, replace the 10% with the 10% input now. Again, copy that to the right. So you notice that these aren't actually significant changes in and of themselves. They're just fairly minor points. But they're minor points that make your spreadsheets far more professional because you don't have these hidden hard-coded values all through your spreadsheet. So there you have it. We have our values that are now parameterized, so there are no more hard-coded values in these cells. Brilliant. Definitely looking more professional than it was to start off with. If I can remind you, this is what the sheet started off looking like, and this is where we are now. Worth noting, our EBIT numbers are exactly the same. Nothing's changed about the way this is being calculated. The only thing that's being changed is essentially the presentation and the layout to make it look more professional, picking up these extra tips and tricks. Okay, here's the next big one. So let's copy all of this across into a new sheet. And I'm going to call this sheet Formula Consistency. Now, I mentioned earlier that people might flame me for the time series that I'd created. And that's because the formulae in these cells aren't necessarily consistent. Here's a trick that you can do. And this is a good way of checking your files before you actually send them out. You can select a range of cells, go back to that Go To dialog box again, click on the Special button in the bottom left-hand side. And this time, we're going to look for row differences. Now, what a row difference is when the first cell in the column, or the first column's formula, is not being copied to the right-hand side. So we're looking for inconsistencies between the first cell and subsequent cells. So if I were to click on this and hit OK, because it's selected cells D3 to G3, it means that these cells are not consistent with this first cell, C3. Okay, fair enough. So what can I do with this? I want, in the first period, the value to be B8, but in the second period, I want it to take last period's value plus 1. So let's use an if function. If this period equals 1, then let's take B8. I'll anchor that down. Otherwise, take last year's end date and add 1 to it. And then I should be able to copy this all to the right. This is essentially what I mean by formula consistency. Having a single formula that can be copied across the right-hand side. So when I hit F5 or go to Special, row differences, there are no differences that are found. So I just need to make sure that I can do that with all the rest of these now. So revenue. I know that revenue is different between period 1 and all the rest. So I'm going to need a formula here that says if the counter, C1, equals 1, then we'll take the first period's amount. Otherwise, let's take last period's multiplied by 1 plus the revenue growth rate. Cool. Now I can copy that to the right. OPEX. We've got these links followed by the growth rates. Now this is a little bit trickier. I'm going to need something that says, do I have values in these cells? So if, let's see, if that's a number in this cell, then you know what? We're going to take the negative of that number. Brilliant. Otherwise, let's take last periods times 1 plus the growth rate. Now this doesn't have to be the actual formula you use. I'm not particularly fussed about how you find a way to make your formula consistent. The key part that I'm trying to highlight here is that the formulae need to be consistent. So there you go, formula consistency. Let's head down to our depreciation grid. Now the depreciation grid is one of those weird ones where often people will have a separate formula for different sections that start at different points, and you've got all these blank cells that sit around. This is clearly not consistent. So we're going to need a formula here instead that will work and apply in all of those cells. So let's have a couple of rules in place here. We're firstly going to need to work out how long each of these blocks should be. They should be about 4 years long in this case. So I'm going to insert a new row here and work out how many depreciation periods we have. That's going to be 1 divided by the depreciation rate. That should be a number. Here's our formula. I'm just going to speed through this formula because it doesn't really matter what it is so much. You can take a look at the end file afterwards. If and C1 is greater than or equal to the number of rows in A42 to A42, and if C1 is less than, where is it, B38, plus the number of rows in A42 to A42. If that's true, then we're going to take the amount that we're getting charged multiplied by the depreciation rate. If that's not true, then it's 0. And I think I've missed off a closed bracket for the AND. What does all this mean? Well, first of all, if the counter is greater than the number of rows through this table we are, then we're in this triangle at the bottom. We're ahead of where we need to be before we start depreciating. Now, if I try to copy this down and across, that's not going to work because our counter is in row 1, and it needs to stay in row 1. So anytime I see C1, I'm going to need to make sure that, so that I can consistently copy this to the right and copy it down, that it's anchored properly. Likewise, I need to make sure that I anchor the reference to column A so that it will copy down properly. I also want to make sure it anchors the reference to the first row too. So when it copies down to the second row, it's selecting A42 to A43 to give me a result of 2 rows. Let's do the same thing with our other rows calculation. And then I think we're done. So I can now copy this to the right hand side, and I can copy this down the page. And now instead of having all these blank spaces, I've effectively got zeros as my result. Now the formulae, the totals and the sums and whatnot that were being applied, assume that it's going to be 0 anyway. But this kind of formalizes that fact. Okay, consistent formulae. If I do a quick check, let's take all of this range, and this is something that you should do with all of your spreadsheets as well. F5 special, row differences. Make sure that there are no row differences throughout your spreadsheet. One final trick. This is really again about presentation. Copy all of this out, create a new sheet. This one I'm going to call units. We're going to insert 2 columns off to the left hand side. And you know what? I'm basically going to refer to all of these as either a date, Australian dollar, percentage, and so forth. Now with these, I'm going to use this style that I created called units. Now a unit type is basically just there to show what the value ought to be. Because we've been talking about 10,000, but is this $10,000, US dollars, Australian dollars, rands, euros? It could be 10,000 of anything really. So this is a way of letting people know that the value that we're looking at here is in standard dollars, not thousands or millions of dollars, and it's in Australian dollars specifically. That these are percentages, and so forth. So it's a good idea to basically apply these to each of your rows. So that if anyone's ever wondering and they're looking through this, they know exactly what each value represents. Let's see, this is a percentage, and this is a number. It's not much, but again, it helps to make your model look far more professional than it would otherwise. So here we go. Here is our, essentially, final model. And we'll include this in the final version of the file. We're just running out of time here right now. You can also probably trim this down. So instead of having a big depreciation grid, you could do it in just a couple of cells instead. Actually, looking at the time, I think we've got time to do this. So let's do this quick example as well. Instead of saying, let's have 5 rows for the 5 years of capital expenditure, we could condense this down into just a single row, because if we had a forecast that was 20 years long, right now we'd have 20 rows of calculations. If you had monthly forecasts that were 20 years long, you would have 12 times 20, which is 240 rows of calculations. So if we can trim this down, ideally that would be great. So we know that we need to depreciate these items over 4 periods. So we're going to set up a depreciation counter, periods to depreciate. That's going to be a number. And we're effectively going to say take the minimum of our counters in C1, or E1 now I suppose, and the number of periods that we're depreciating. So effectively we're looking back how many years of CapEx are we including in our depreciation result. And so we can work out what is our depreciation using a really cool combination of functions, being sum and offset, which will allow us to take our capital expenditure, move it 0 columns and 0 rows, having a result that's 1 high and negative number of periods to depreciate, and multiplying that back by the depreciation rate. Now, the exact way that this is being calculated and how this works, don't really have time to go into. If you want, you can check out our website, go to the thought page and look up depreciation. But essentially, this gives us the same results as the entire grid does. You can apply this logic regardless of how many rows or how many periods of depreciation that you actually have. So let's relink our financial statements, put them in place. Let's delete our old depreciation block. And there we have it, a nice, neat depreciation set of calculations. So hopefully that's given you some ideas as to how you can go from what was essentially a pretty ugly spreadsheet, something that's very clearly a pleb job, and turn it into something that looks far more professional. That was the goal of this session, to try and how to go from a pleb presentation to make you look like a pro. So hopefully you've taken some stuff out of this. Do make sure that you submit your evaluation for this session. If you really like this, either hit the link or take the QR code and scan it and fill out the survey. Let us know how you think the session was. I hope you're also doing that for all the other sessions too. If everyone's taken that link now, I'm going to move on to the next slide. You've probably seen this slide a couple of times as well already as well. The Excel team is looking for research participants, so if you're interested in taking part, please do check that out as well. And to wrap up, if you did have any questions, if you want to check out the resources that I mentioned before, please do check out our website. Feel free to get in touch with us, either email or hit me up on LinkedIn or Twitter. I'll be honest, I don't update Twitter as often as I should, but we'll hopefully do so after this. Anyway, thanks for coming. Thanks for enjoying the session. Please do check out the next session, and I hope you enjoyed. Thank you.